Hi, today we'll be taking a look into the ambiguous case for the law of sine. Now, the main idea that we're going to try to discuss here is that when we use the law of sine to solve triangles given a side-side angle form, we can encounter situations when more than one triangle can be created with the given information. There are times where you've been given information about a triangle, and if that information is being given in the form of side-side angle, then there are times where we might encounter two different triangles that we can create given the same piece of information from the problem. Now, why is it that we can find two different triangles with the same information? Well, we got to think back about geometry. Because in geometry, when you were proving congruency, one of the cases that you saw is that for side-side angle, it does not prove congruency. What this means is that if you've been given any triangle, and the information that you know about this triangle is a side-side angle, because you cannot prove congruency, it's because this triangle is not unique. And because this triangle is not unique, that means that this triangle can be written down in a different form. And that's the connection between the congruency and the ambiguous case for the law of sine. That because you've been given SSA, and you know from your previous class that SSA does not prove congruency, then that means that that same angle can be written in different forms. Now, one thing to notice here is that we're going to be looking at some cases for the law of sine. One thing to notice is that for the following cases, we will assume that the opposite side is greater than the height of the triangle. This is important because if the opposite side is not greater than the height, then we will not have a triangle at all. That's a whole different discussion. We're not going to be mentioning that in this video, but that is one thing to consider. That if you've been given a triangle, you find the height of that triangle. And if the opposite is less than that height, then you will not have a triangle overall. So in order to avoid that situation, we're going to assume that for these cases, the opposite side is greater than the height. So with that said, let's take a look at case number one. Let's take a look at case number one. Okay, well, let's label our triangle. Let's look. Let's finish up our triangle. Let's say that this is 8. We know that B is 8. So let's just say that if for this length to be 8, it's going to land somewhere in here. All right, well, let's actually label our triangle. If this is B, then that's little b. If this is little b, then that means that this is big A. And that says that this is C. Okay, so notice that we have our triangle right here. We just use the information that we know. We know that it's a side-side angle triangle. Now, one thing to consider is that when you have a side-side angle, you can pay attention to the opposite side of the given angle. Because one way that we can explain the following case is to think about this line. Imagine that this line works as a pendulum and moves along this line. Imagine that this line, you can kind of like drop it and it follows this form and it's going to be landing over here. So notice that if we do that, our new side B is going to land somewhere in here. Which means that we have actually created two triangles in this case. Because notice that our first triangle, so we can have two triangles. We can have two triangles where the first triangle was the triangle that we had originally. You know, it was the first triangle that we had originally where it was 40 degrees. When it was C and it was A, and we know that this was B was equal to 8 and A was equal to 10. This is the original triangle that we had originally. And if we follow this pendulum right here, if we follow this line and we kind of like drop it like if it was some kind of a pendulum, it's going to land somewhere around here. And that might be our second triangle in this case. Because now, notice that if we move that line like if it was a pendulum, we're going to end up with a different triangle. But one thing to notice about this triangle is that we're still going to use the same information. We still know that this is C, this is B, and this is A. We still know that A is 10. We still know that the angle is 40. And we still know that B is 8. Notice that we're still using the same information that we've been given at the beginning of the problem. It's just that this line, because the opposite line is less than the adjacent line, then when we kind of move that line along this pendulum, we might create a whole different triangle. So one thing to consider is that when the opposite, which in this case, the opposite side was 8, when the opposite is less than the adjacent, we're going to encounter situations where we have two triangles. And notice that because this line, it gets moved along this pendulum, there might be different values for C, and there might be different values for A as well. So that's something that we're going to encounter once we do a problem. Because yes, we might still have side angle, but if you just take a look, the angles are not exactly the same. So we might have different values for C if we compare the first triangle with the second triangle, and we compare the first triangle with the second triangle. So that's one thing to consider. Now, what happens in our second case? Where in our second case, let's just make our triangle here. What happens in our second case? Where the second case, we can see that under our second case, the adjacent, which in this case is 12, here the adjacent is less than the opposite. What happens if we kind of like do the same idea as a pendulum? All right, let's see. Let's just say that this line is going to be rotating about this point. So if this line, it gets moved as if it was some kind of a pendulum, notice that it's never going to be touching this line. Now, the reason is because the following. You know that this line is 15. So if we kind of like rotate around, like if it was some kind of a circle, let me try to be more exact on this. Imagine that it gets moved like if it was some kind of a circle. Let's create a circle where this is our center and the radius is 15. Notice that if we move it around it, it's never going to be touching any of the lower part of the triangle at all, because there's no way that it can touch it right here, because we know that this length is 15. The radius of the circle is 15, where this side is 12. So it will never touch. There will always be some kind of a gap between this line and any part of the or any part of the triangle that we have in here. So when the adjacent is less than the opposite, we will have just one triangle. And if we have one triangle, then it's just the original triangle. So just to recap here, when we have the opposite side, when the opposite is less than the adjacent, we're going to encounter two different triangles, still using the same information. And when the adjacent is less than the opposite, just like it's showing here, then we have just one possible triangle. All right, so let's see, how does this look actually into practice? All right, let's look into example 1. All right, so let's see, how can we use the previous information in an actual problem? Cool. Let's look at example 1. We're going to build a triangle. All right, let's just draw some triangle right here. It doesn't matter. This is just an estimation. So we got our triangle. Let's just label it. This is A, this is B, this is C. Little a is 8, so that means that the opposite of A is 8. Little b is 10, so that means that the opposite is 10 right here. And we have that angle A is 34. Now our objective here is to find all the possible values of angle B to the nearest, I guess it got cut off. So let's say to the nearest tenth. Cool. All right, let's see. What do we have here? So notice that just by looking at the problem, we can see that we have a side-side angle. Okay. We know we have a side-side angle. So now let's see. Is it going to be the case where we have one triangle or two triangles? Well, let's take a look. We know that the opposite is 8, and here the adjacent is 10. So we have the case where the opposite is less than the adjacent. And if we look at our previous slides, when the opposite is less than the adjacent, we're going to have two different triangles. So let's just keep that in mind. Okay. Sorry about that. All right, so let's keep that in mind, that we're going to be having two triangles. We'll worry about the second triangle in a second. Let's actually try to solve for the angle B in this case. So our objective is to solve for angle B, because that's what we want here. So one way that we can do is just to apply the law of sines that we know. So we're going to be applying the law of sines, and according to the law of sines, we're going to get sine of 34 divided by 8 equals the sine of B divided by 10. All right, let's solve for angle B for this triangle right here. To properly solve for B, we're going to get rid of the denominator. So let's multiply 10 to both sides. That way this cancels out. Now we're going to have 10 sine of 34 degrees divided by 8. And this is going to be equal to the sine of B. And notice that if we want to get B by itself, we need to multiply by the inverse. So we're going to multiply by the inverse on both sides. That way this cancels out with this. And now we can see that B is going to be equal to the inverse of 10 sine of 34 degrees divided by 8. All right, let's see what that value is. Let's take a look in here. So we're going to find our inverse. So the inverse, and we're going to be doing 10 times the sine of 34, close parenthesis. So this parenthesis goes here, over here, and then we're going to divide it by 8. Let's make sure that our calculator is in degree mode. All right, perfect. So now, in here, we have that angle B. Let's say that angle B. Angle B is equal to 44.3 degrees. In here, we can see that B is equal to 44.3. But we also know that we need to have two triangles. So we're going to have, let's call it that we have two triangles. So our first triangle, let's draw it here. So our first triangle, we still know that this has to be 10. We still know that this has to be 34. Okay, we still know that this has to be 34, but we know that angle B has to be 44 degrees. So that's, let's just extend this a little bit here. That's going to be about right here. Because if we still have A right here, we still have A right here, we still got B, and we still got C. And we know that angle B is around 44 degrees right here. So B is 44.3 degrees. So this is our first case. So we might have a triangle that will look like this, where we have 34, 10, and this is still 8. Notice that it's the same information here. 34 degrees, 10 as a length, 8 as of little a. But now, how does our second triangle looks like? how does our second triangle looks like? Well, to find the angle of B under our second triangle, let's write this down. To find B for second triangle, we do 180 minus B from the previous triangle in here. So angle B, let's call this B prime. Angle B prime is going to be 180 minus whatever we got under our first triangle here, which is going to be 44. So we're going to do 180 minus 44. Oops, that's an extra 4. 44.3. So that's going to be equal to 135.7 degrees. So that means that we're going to still have a triangle. We're still going to have some kind of a triangle right here, where again, originally angle A, it's still 34. Side little b is still 10. But now angle B, which again, this is A. Now angle B, right here, angle B is going to be equal. Angle B is going to be equal to 135.7 degrees. And again, we're still using the same information, so that means that the side is still 8. So here are our two triangles. We have our two triangles. That's the first triangle that we encounter. And this is the second triangle that we encounter. And the way to find angle B under the second triangle is just to obtain the information for the first triangle and subtract it from 180. Now, the reason why we need to subtract it from 180, that's actually because of the unit circle, or one way to explain it is using our unit circle. So here's an explanation as to why we need to subtract from 180. Let's just build a random unit circle. All right, so we got a circle right here. Cool. Let's just label our axis. Let's say this is my x-axis. And let's say that this is my y-axis. All right, perfect. So we know from our unit circle, let's take in consideration angle 30. Cool. Take in consideration angle 30. And from your unit circle, you will see that you have square root of 3 over 2 and 1/2. Now, if we try to find the sine, if we try to find the sine of 30 degrees, this is equal to 1/2. Because remember, when you've been given a triangle, sine is a y value, which is 1/2. But notice that in this unit circle, there's also another angle that if you take the sine of it, it's equal to 1/2 as well. And that is, what would happen? Let me do it in different colors so we can differentiate. Imagine that we have an angle of 150 degrees. Where on the angle of 150 degrees, we have the coordinate point of negative square root of 3 over 2 and 1/2. Where if we take the sine of 150, if we take the sine of 150, we're still going to encounter 1/2. So notice that there are two ways, or there are two angles right here that will still give me the same result. The sine of 150 is 1/2, and the sine of 30 is 1/2. Now, one way to look into it, another way to still get 150 is to do 180 minus the first angle that give me 1/2, which notice that this is 150. The reason why is because if this is 30 degrees, If you take 30 degrees from the other side, this is still 30 degrees, you're still going to obtain to 150. We know there's going to be always 180 because if you take a look at the angle of a whole line, that's 180 degrees. So 180 minus 30 is going to give you 150. And that will always work for any point on the first and second quadrant. We don't really pay too much attention to the third and fourth quadrant because the sine values under the third and fourth quadrant are negative. This is a small explanation as to why we need to subtract 180. Or we need to subtract 180 minus the previous angle in order to obtain the angle for the second, or for the angle for our second triangle. So right now, as your entrance ticket, I'm going to be asking you to just state the number of possible triangles that can be formed using the given measurement.